Okay, so we are now into the Holocene. We left the last chapter on climate and human interactions coming into the Holocene. Of course, we'll go into many more details here on the climate, on humans, on especially the evolution of agriculture, because agriculture is arguably the biggest factor that affected our evolution over the last 10,000 years. And obviously by then we had lost the Neanderthals, and maybe Floresiensis would have been around in some cave in Flores, but we don't know that for sure. But the anecdotal stories about seeing such a small little human being persist in Indonesia and Malay regions, which is surprising because those almost sound like eyewitness anecdotes. Okay, so the idea again is still the same. Environmental determinism is where we say the climate change, climate perturbations explain a lot of the evolution, not only out of Africa, diaspora, but adaptations, genetic evolution, adaptability, responding to environments epigenetically, and of course social structures, complex social structures, governance, militarization, everything. And the details, of course, we have already mentioned several times, whether agriculture was attempted before the Holocene and it was just not possible because of the wild swings in climate. We are looking here at the temperature on the surface of the ice, obviously that's why it's so cold. And we are looking here at the MIS stages that we talked about with these high frequency Dansgaard-Oeschger events, Heinrich events, and marine isotope stages, and the hiccups we have had coming out of the last glaciation with the older Dryas, the Bowling-Allerod, the younger Dryas into the Holocene, and the contrast is quite obvious here. The temperature swings and the frequencies here are generally much more limited than what we had before. And easiest way to put environmental determinism into action is to say this made agriculture possible. Of course, then we have to wonder whether people like Paul Ehrlich, Jared Diamond, Fagan, there are many names we will look at who interpret the evidences differently, whether agriculture was made necessary by the disappearance of resources for hunter-gatherers, or was it that climate became stable so our practices became more stable and more expansive as well. And there is also arguments that even the hunter-gatherers were already eating some cereals and wheat, nuts and so on, which were indications of some move towards agriculture. Domestication of crops itself has to be understood better, of course, and whether domestication of some animals had already happened by the hunter-gatherers as well. For example, dogs evolved out of multiple groups of wolves, and they were bred over time to become domesticated along with cats as well, and their properties of herding sheep or helping with hunting, etc., have been used effectively over time. All those things have to be considered here, and whether the appearance and disappearances of civilizations, starting with the Akkadian, the oldest one we tend to talk about, were really related to temperature perturbations, or whether they were really collapses and extinctions of civilizations, or whether they just gradually disappeared, and whether that was itself was related to climate change, and whether sophisticated societies evolved independent of agriculture, militarization happened independent of agriculture, or whether military adventures were related to droughts and lack of food production, or was it a lot of food production and wealth that motivated kings and queens to build militaries and go on adventures to acquire other, invade other kingdoms and so on and so forth. So all those sorts of questions don't get answered very well because the evidence is not that detailed, even though it's much more detailed than before. This is another view of looking at a longer time scale through our MIS stages that we have talked about. This is temperature anomaly, and this is accumulation scaling of Greenland ice sheet. And both of them indicate the same thing we talked about, the rather stable, benign Holocene period. And then of course different reconstructions differ from each other a little bit. Nonetheless, the question is also whether the small anomalies that occurred over this warm baseline did have large scale impacts. They include volcanoes, natural variabilities like El Nino and North Atlantic Oscillation and so on, which also affect agriculture through anomalies in temperature, precipitation, humidity and so on. So what was the interplay? And we know by now that modern agriculture has become so intensive in land use and chemicals used and scales of food production that agriculture is a major contributor to greenhouse gases. Bill Ruddiman argues that the evidence of agricultural impact on deforestation and CO2 increase does exist through the Holocene. So how extensive was the environmental impact? The reconstructions get into various details. This one is basically about a debate on some of the older data that indicated a cooling over more recent periods, but this was of course a local Greenland temperature anomaly and not a global indicator of a global cooling. So reconstructions from past climate changes program and HADCRU global temperature anomalies show you that there is a uncertainty band around this Marcotte et al. Reg EM reconstruction. So that's the Greenland reconstruction, and right now there is not much debate that human impacts since industrial revolution have pushed us out of the envelope of the variability over the Holocene in terms of global warming. Of course, global warming tends to come with regional patterns. North Atlantic is not warming as much, or maybe even cooling, for example, because of the impact of global warming on the meridional overturning circulation that we talked about before, and we will visit briefly again. This figure we looked at before from Tony McMichael's paper on climate and health looks at the post-glacial warming after transient rapid cooling due to Younger Dryas. So we'll revisit Younger Dryas again. We came out of it, and then there was a warm, wet period, greening of Sahara, monsoon abundance and so on. So Holocene climatic optimum 1 and 2 span the warm periods, but there was a cooling and Sahara dried up, so populations expanded away from the Nile River Delta, Nile River into western parts and eastern parts of Africa, and then collapsed back again towards the water. So this movement to find water and agriculture, agricultural viability have gone on through the Holocene. So this is before the Common Era, and this is Common Era here. And there are, of course, attempts to link climate changes to things like Roman warm period, so expansion and collapse of the Roman Emperor, keeping in mind that collapse may not be the right word. 536 Common Era event, which shows acute cooling, and it should be mentioned that not all models can capture these kind of coolings either. Nonetheless, they are used to interpret some of the archaeological evidences in terms of agriculture, human climate interactions. Medieval warm period and Europe, where Greenland made room for Vikings to colonize it, even try agriculture there, and made trips to North America. And then came increased volcanic activity and sunspot activities, end of the medieval warm period, demise of the Vikings, and then into the Little Ice Age, which was somewhat of a local European climate event, much more predominantly European, with evidence in China as well. And then came the Industrial Revolution, and why the Little Ice Age ended. Some argue that all the pollution from the Industrial Revolution, fossil fuel burning, accelerated the glacier melt, because when you put dirt on glaciers, albedo goes down, they absorb more heat and they melt faster. and of course we are headed here into projected warming, which we did keep debating about 1.5 degree target, 2 degree C warming target, and so on. So in the next chapter, the last chapter, we'll come and look at modern humans, future climate, and that interaction as well. Of course, throughout the Holocene, coming out of the last glacial maximum, the CO2 changes have been consistent with what we expect under glacial, deglacial stages of natural variability, and this only goes up to 1950, and at which time we were in the range of less than 320 ppm, but obviously by now we have crossed 420 ppm. But you can see that there are transitions into the Holocene, and then dips and increases which correspond in ice cores and so on to reforestation, deforestation. Black plague, for example, in the 1400s would have killed lots of people. Abandoning of agricultural land and regrowth of forests would have drawn down some CO2 and so on. So all those kinds of details exist here. Little ice age is shown here with a slight dip in CO2 as well. So that's the medieval warm period there. So we'll come back and discuss more issues about how to interpret all the Holocene data, archaeological proxy data, and historic documented evidences since about 3200 years ago. And the prehistoric period is before 1200 BC, basically couple of million years ago, when we start talking about earliest Homo lineages. So there are, of course, multiple interpretations of the evidence. We will see many quotes from books like from Burke and from Fagan and so on, which show you how people think about agriculture, climate, social structures, and what drove what. That's always a cause and effect, are always tricky, but nonetheless they are very important, especially because we also want to see where we are headed with our global warming that's happening now. Okay, so we'll come back and look at more about natural and anthropogenic variability, because humans were beginning to have an impact on the climate through the Holocene. So were there already evidences of human impacts on climate, and how natural variability itself changed. El Nino in terms of its duration, frequency, and intensity, North Atlantic Oscillation and its impact on European climate, precipitation, ecotones, vegetations, forests, agriculture, East African monsoon, East Asian monsoon, American monsoons, and so on and so forth. So we'll try to string together a nice long narrative. This is a longish chapter because even though in the book it's not that long, I took lots of references from different places, a lot of material to add additional points along the way. So it's going to be long, but it's very interesting as well. So we'll continue when we come back. Okay.